Morning everybody, how are you? Today we'll have a second video about logarithms. Let's start with recapping, do some revision from last time. So I'm putting here a few equations. Just let's double check that we know how to use the basic rule. What is the basic rule? Whenever you have log a to base b equals c, you can go to an exponential form which says b to the power of c equals a. This is being written in logarithmic form, and this is being written in exponential form. Your baby is to go back and forth. If you can't go back and forth, you have a weakness. Let's do some question as a revision from last time. What is 5 to the power x minus 2? That's the base. X in the power. Then I have to turn this into log. I keep the 5, I switch, equals x minus 2. Bring it over there. 2 plus log 11 to base 5 equals x. Okay? If you wish to find the answer, yes you can. If you don't want to wish to find the answer, you can leave it that way. But may I advise you with something? You can rewrite the answer like this as well. Log 11 base 5 plus 2. If you put 2 next to this, I would prefer you that you put it in bracket. Remember, whatever the answer must be negative. Then its modulus is positive. So it doesn't matter if it's positive or negative. Think about that anything here comes out to be positive. Otherwise, it won't work. If I want to go to calculator, if I wish, then I go log 5, 11 outside the plus 2. You may round it to 2 decimal places, which is what? 3.49. That if it was exponential form. If it was in logarithmic form, then I'm going to go upward. So it's going to be 5 to the power of 11 equals x, where x equals, well, what is 5 to the power 11? You know what? Who cares what's 5 to the power 11? It's too big. Leave it. How about that one? It's exponential, but I have here one. So what I do, I take it over there. So e to the power of x equals 3 minus 1 is 2. And this is exponential. I'm standing here, I want to go backwards. So I'm going to make it like what? Log e switch 2 equals x. You know what that reminded with? This is the definition of the logarithmic function, which says natural logarithmic of 2, len 2 equals x. So whenever you see log to base e, that's simply len. And when you go to your calculator, you can say len 2, which is 0.693, blah, blah, blah. I would have left it like this. Leave it. How about that one? It's logarithm. It's an logarithmic form. Take the 3 over there. Len x minus 1 equals 2 minus 3 minus 1. But don't forget, the log means what? The len means log to base e. So, you are standing here, you want to go down there. This is the base e to the power minus 1 equals x minus 1. Take the 1 over there. So what happens? X equals e minus 1 plus 1. I can go with the calculator, I can leave it that way. It doesn't matter because shift len negative 1, that one plus 1. And the answer is 1.37. So you can always leave the answer exact, or you can run the answer. But it doesn't matter if you leave it this way. Well, it depends how you see it. If you're on an exam, you were given an answer, double check. Am I giving it exact, or should I use a calculator and use that one? That's your job. Number 2. Last time we talked about a logarithmic function, and there are some properties about it. So now I'm suggesting just anything comes out in my mind. So the function in front of you is called f of x equals 3 times len to x plus 1 minus 4. Well, let me ask you a few questions about it. So I want to determine the following. What is the vertical asymptote? The vertical asymptote, as I said, it's whatever inside the bracket equal to 0. 2x plus 1. And when you solve it normally, as a normal algebra basics, divided by 2 is a negative half. Alright? That's called the vertical asymptote. The domain depends on the vertical asymptote. Some people don't see it. Well, basically, I can see it. So x is larger than minus half, And I can either put it this way. Some people say, wait. I cannot see it. How come you make it? Well, let me tell you the real game behind it. Shall I tell you that? Because I don't want you to memorize it. You know that the value in here, where is it? The value of this function, whatever inside, it cannot be 0, nor can be negative. So it must be always positive. Therefore, you will take whatever inside the bracket. It's got to be always larger than 0. No matter where you go, this value inside the bracket, even if it's an x, or 2x, or 3, or x minus 2, x plus 5, whatever inside there is got to be positive. Because the len or the log of something negative or 0, it doesn't exist. Now I can avoid graphing right away. So when you solve that thing, and when you divide it by 2, and how do you read that? X is larger than minus half. You can interpret this in a different way. Minus half all the way to positive. You can see it better if you wish when you have a graph. What's the y-intercept? To find the y-intercept means x equals 0. Like the x-intercept. How can I find x-intercept? That's when yields to y equals 0. Well, let's go take x equals 0 and plug it in there. How about this? 3 len 2x means 0 plus 1 minus 4. Remember, this answer is going to be positive no matter where you go. But I don't like trying it here all the time. But if you write it like this, you are absolutely right. That's the best way to write any question. Anyway, 2 times 0 is 0. 0 plus 1 is a 1. What is 3, 1? What is 3 len 1? Go to your calculator, 0. 0 times 3, 3. So the answer is what? Negative 4. What's the coordinates? If the question asks you to find the coordinates, you've got to give me the coordinates. Because I don't know if you understand this and this makes that one. Some people don't understand that. So I've got to see it. If I don't see it, but if I ask you only find the y-intercept, I'll be more than happy that you give me that. I'll be satisfied. So remember, you may say, but you said the x, y. I'm explaining here. I'm giving you how would you tackle a question. Whenever you see a question that talks about find the coordinate, that's it. How about this one? If I want the x coordinates, how about that one now? Also the same. Take y equals 0, plug it in there, and you said the 5x equals 3 len 2x plus 1. And guess what? Take the 4 over there. Divide both up by 3 by 3. Maybe you should remember by now that len means what? Some people say, oh, I forgot. You can't forget. I put the 4 over 3 here. You know why? Because I get used to convert the logarithmic expression to exponential by putting the number on the right hand side. That's me. So e to the power 4 over 3 equals 2x plus 1. What do I do next? I will take the 1 over there. What do I do next? I'll divide by 2. So at the end of the game, x would be what? E to the power 4 over 3 minus 1 all divided by 2. You may leave it that way or simply find the answer. All right? So did I actually do it? No. Let's find out the answer. All right? So e to the power, shift len, open bracket 4 divided by 3. All right? Minus 1 divided by 2. You may leave this answer as 2 decimals or 3 decimals or 1 decimal. It depends how they ask. All right? You will double check, you can plug in and substitute. These are supposed to be from the first lecture we did. So what I'm doing today, I'll just recap for you, which means that I reviewed things for you. Now, actually there's not much left in this except a few 2 rules you have to know. 2 rules, you have to be able to use them properly. What are these 2 rules? Let me give an example. All right? I had a paper. I don't know where is it, but it looks like it doesn't matter. Let me take one of these questions for you, please, and then find out the rule. Log x plus log 2 equals log 12. This is one equation I want to solve. And let's put another question. And know the difference between them, please. Question 2. Then I'm going to give you another 2 questions. Then I'm going to tell you, thank you very much. Log 2 this and log minus log x plus 1 equals 2. Don't forget, what's the base here? 3. What's the base over there? Nothing? No. Actually, it means 10. But I don't have to put it. But guess what? This is 10 but equals to also log 10. So either the base is the same across the equation, or you have an equation without log on the right hand side. Each one they are the same as a start, but the finishing is different. So let's double check. Their simple rule says, whenever you add the logs, you multiply these. Let's do it. So it's a log x times 2, same base, equals log 12, same base. That's cool. So, what happens 2 times x? Well, it's log 2x equals log 12. I don't have to write the base 10 as I told you before. All right? Since both of them are the same log, same base, I could conclude that this equals this. And when you divide both sides, x equals 6. I want to keep it for a minute so you can compare this one by that one. All right? These skills, sometimes you learn it by memorizing the technique. But you have to apply the rule. What is the rule over here? Simple rule. It says log A plus log B. That equals log A times B. That's it. You can go forward or you can go backward. That's a basic rule. And here, we have a minus over there. That's right. When we have a minus, ladies and gentlemen, it's good to remember, when we subtract, we divide. When we add, we multiply. So, maybe I should write it for you as a rule. Log A minus log B equals log A divided by B. So when you divide this one, but remember, there are many other issues that's wrong. Sometimes people say log A over log B. Some people say, here, I understand, I'm so good. It's a log A times log B. Remember, these are misconceptions why practice makes perfect, and you don't practice, and you don't have a lot of time. Now, guess what? I'm looking at this step here. Look at this step. It's important. Compare this step with that step. What do you notice? Don't forget, my base is not 10 here. Common base must stay. Common base stays. But you have on the right hand side a log. So the difference between this and that, this equation has logs on both sides. They cancel out if they have the same base. But in here, one side of the equation has a log, the other doesn't have. That's easy. Let's apply the basic rule. What is the basic rule? It says the base 3. Switch those. Equals 2 plus x and x plus 1. And 3 to the power 2 is 9. 2 plus x, x plus 1, and don't forget 9 over 1. So we can cross multiply. So the game is in here. Here, as a base, power, and answer. There, now, both has bases. Both has, answer. So let's find the answer. Cross multiply. 9 times x, 9x plus 9. This times 1 is a 2 plus x. Put the x's together. 9x minus x. And put the numbers together. 2 minus 9. And here's 8x and here's minus 7. divide both sides by 8, that would be the answer. All right, so remember, sometimes a smart idea is to substitute this answer in there to check. Or even the 6. Plug it in here, plug it in here, hopefully it equals to that. For example, log 6 plus log 2, 6 times 2 is 12. Is log 12 to base 10 equal to that one? Yes. Here, calculator. So it's very wise, very tricky sometimes to check your answers. How? Just substitute them. Sometimes it works, sometimes it doesn't work. Sometimes you may have 2 answers here. One of them maybe have to be dropped. One of them has to be accepted. Sometimes both are not good. Sometimes both are good. I don't know. Your job is to double check. Let's put another 2 examples. Len equals len. This is question number 3. All right, gentlemen. And let's put another question over there. And let's go to question number 4. Also len, beautiful. Yeah. It doesn't matter if you have len, by the way, or if you have log, because the only difference between them is the base. Those questions before were base 3, base 2, base 5, base 10. This one are only base of e. So I have a minus. What does the rule say? Minus means divide. Sorry. What do you mean divide? That one divided by the second one. And guess what? I want to make this plus. So I don't want to common factor and end up with having lousy thing. Equals. Since both of them are len, I know some people say, but sir, this is 0. I don't want to do that. I just want to make sure you got the idea. If the len equals to the len, they will cancel out. So what you end up with? Cross multiply. 2x times 1, that one. This by this is that one. Put the x together. 2x minus is an x. Put the 2 together. The x is a minus 3. All right? Hey, I'm done. I'm happy. I am so happy. Is my calculation correct? Let's double check. Take the negative 3, plug it in here. What's negative 3 and negative 1? Negative 4. You don't have an answer for negative 4. I'm sorry. Look. Len, negative 4. Come here. Negative 3 for 2, negative 6. What's negative 6 plus 2? Also len negative 4. And when you subtract them, it's supposed to be the same and 0, even though this is 0. So sometimes it's very important to see it, that even though this could make sense, you know why? Because if I took the absolute value, the absolute value, then len 4 minus len 4, which is len 4 over 4, which is len 1, even though the question was 0. So I just want to that you can think and raise questions. Sometimes it's very smart when you try, you don't see things and you raise questions. How about this question? We have a plus. So len 2x times 5, because when you add, you must equal 0. So this is called len 10x equals 0. And remember, len means what? Log base e. This is logarithmic. Let's turn it into exponential. This is the base. Switch those. And guess what? What is e to the power 0? 1 equals 10x. And when you divide both by 10, then, x equals what? 0.1 or 1 over 10. All right? You can plug it there and you still can double check and you will not end up with any problem. So gentlemen, I want to advise something for you before I end up my class. All right? I'll put up some questions. My advice to you is try to solve them from now. By the time we have a class on Thursday or Wednesday, then you could ask questions on Wednesday or Thursday. But if you assume that you are having Eid, which is true, Allah يبارك فيكم وكل عام وانتم بخير من حقكم, but sometimes during Eid, like today is third day of my Eid, like your Eid and other people's Eid. What is going on? It's boring. We're doing nothing. We cannot get out. So I suggested, why don't I give a chance for the people who like to do, just look through it. You have 2 videos. I am sure with you have a good mind, you can understand things. So this is the page I'm recommending. And that's the question numbers you can discuss or you can solve. And if you have problem, you can ask. All right? There are 3 locations. If you look at page 5, you may focus or you may try these. I'm trying to give you things related to what I teach. Sometimes not everything you want to try. If you look at page 8, please, or maybe let's say page 7. Okay, 12, and question number 20. All right, and if you look at page 9, then my advice to you is to go to 16 and 17. And there's a nice page I want to make sure that you read it, which is page 13 and 14. There are 2 examples about functions. I gave you the same, but I changed some numbers. It's good to practice because I'm going to bring 4 simple questions. Find the range, find the mean, find x intercept, find oneself, find the vertical asymptote. So you got to do this in a matter of seconds. You got to be good in algebra. These are called exercises 6 and 7. If you do these questions, look at it carefully again. These are the questions. Okay, and that's the page. Now, the worksheet, the lecture note, it doesn't have numbers, unfortunately. So you better count 1, 2, 3, 4, 5, until 18 or 15. All right? So page 5, page 7, page 9, page 3, and 14. I could put really very tough questions. That's not the point. I want to make sure that you've learned something out of all of this. I'm going to put 1 more question and that's it. Let's call it the amazing 5 question. Question number 5. How would I solve a question in a different approach? Some people, they see books, they look at the, the YouTube, and they see the way you do it differently. How about if we see a question that way? I've given you before questions like this. 4 to the power 2x minus 1 equals 5. This time, I'm not going to solve that way. That's an easy way to do it. What happens if I make this question both has power? That's called funny question number 5. It's not funny. It's so easy, straightforward, but you have to escape. Remember before when I used to tell you x squared equals less than 8. What do? You take square both sides. Yes. And if I tell you x plus 7 equals 9, what do? You subtract 7 like little kids. How about if I say 3x equals 12? What do? You divide both sides by 4. What happened this time if I simply apply that rule on that one? As I told you in lecture 1, you can do it by using my basic rule, or you can do it by taking log to both sides. So let me write what I just want to do. I'm going to take log to both sides. And don't forget, when I say take log, I did not say any base, so it means 10 by default. So let's find out. Log, this is your line, you're writing on 4 to base 2x minus 1 equals log 5 to power x plus 2. The power should go down. 2x minus 1, you have to put a bracket, equals, don't forget that this will have to go down like the one before, x plus 2 log 5. Now simply, I got rid of the part by applying the rule. Which rule? The rule that says log x to the power y equals y times log x. Remember that thing. That will not hurt. If you have a calculator, I can tell you that log 4 is what? 0.6 roughly. And how about log 5? Roughly 0.7. You all are good. You expand the bracket. Expand the bracket. I don't believe you have a problem. All right? So when you multiply this one out, 1.x minus 0.6 and 0.7 plus 0.7 what? 0.7x, Saifian, 1.4. Put the x's together, 1.2x minus 0.7x. Take the 6 over there, 1.4 plus 0.6, which is roughly 2. And in here, 12 minus 7, 0.5x. Divide both sides by 0.2, the answer comes out roughly 4. If you do it in any other way, it would be like 3.99 something. So guys, I just use a new technique. You can solve it anytime you want. But in that situation, I would rather for myself, even though I taught you the basic rule. What is the basic rule? That if I see a to the power of b equals c, I can do it by saying log c to base a equals b. I did not here say take log to both sides. Yes, I can do it, but I like to push the one that works for everything. It works for that. It works 100%. But I don't want to waste your time, because I am sure you're going to see my lecture and you're going to see many books. They are talking about, let's just take log to both sides. So remember, you may do that. Anything you can do. All right? I think by reading and by going through my lecture notes and by doing these questions and pay attention to the things I did in video 1, video 2, you should be more than perfect. Because you've got the solid background, chapter 1 algebra, and you've got the solid background in what? In video 1 of logarithms. Have a nice day.